Hey there guys, welcome to my walkthrough of AQA's Further Maths Specimen Paper 1. Now, this is for the new spec with first exams in 2020, I believe, but if you are revising for the old spec, it's all relevant. So, this looks pretty much like AS level maths, so I'm going to put all of my AS chapter playlists down below in the description. I will also put the paper down there, and if I do it, if you guys want it, I will put the paper 2 walkthrough down there too. Okay, let's go. Okay, 1a, y to the 6 times y over y to the m is y to the 4. We want to calculate the value of m. So, if we simplify what we have up on top, y to the 6 times y is y to the 7. So y to the 7 over y to the m is y to the 7 minus m. Now we know that is equal to y to the 4. So 7 minus m is 4. So m is 3. And there he is. Cool. Okay, 1b. A to the n times a to the 5 is a to the 5. Work out the value of n. So, a to the n times n, a to the n times a to the 5 is a to the n add 5. Now for that to be equal to a to the 5, n is gonna have to be 0. Cool. Okay, 1c. C to the 5 to the power p is c squared to the power of 6. Work out the value of p. So, when powers are separated by brackets, we multiply them together. So, we've got c to the 5p is c to the 12. So, 5p is equal to 12. P then is 12 fifths, which is, you can leave it like that, it's 2.4. Cool. Okay, question 2, answers to solve. The cube root of 7x minus 13 is equal to 2. So, first of all, we need to undo the cube root. So we're going to cube both sides. So we get 7x minus 13 is equal to 2 cubed, which is 8. Add 13. 7x is equal to 21. Divide by 7. X is 3. Okay, question 3, we have an identity. So, 3a times 2x minus 1 add 4 lots of ax add 5 is identical to 60x add b. Find the values of a and b. So, first up, expand the brackets on the left. So, 3a times 2x is 6ax. 3a times minus 1 is minus 3a. And then we get 4ax. So add 4ax and then add 20. Now that is identical to 60x add b. Okay, let's simplify on the left. So we got 6ax add 4ax, and that's 10ax. And then we got minus 3a add 20. And that's identical to 60x add b. So this identity means then that we have to have the same amount of x on the left and right, and the same constant term. So the constant term is the bit with no x attached. So the first thing we can say is that our 10a has to be then the same as 60. Because 10a has to be the same as 60 because we need to have the same amount of x on both sides. So from that, a is 6. Now that we know what a is, we know on the left hand that we've got 60x minus 3a. So minus 3 times 6 is minus 18. Add 20. So we got plus 2 now. And that is identical to 60x add b. So b has to be 2. Cool. Okay, question 4. ABC is a straight line with A to B to B to C in the ratio 5 to 2. We know the coordinates of A are 3, 7, and the coordinates of B are 5, 5.5. We want to work out the coordinates of C. So, we know then, altogether, well, we know that A to B to B to C is in the ratio 5 to 7. So, 5 to 2. So, altogether, this line is in 7 equal parts. Now, AB is 5 parts. BC is 2 parts. So, what we're going to do is work out how we get from A to B. So, let's think of this as a vector. A to B is, well, we're going 2 to the right, and we are going 1.5 down. So our vector is 2 minus 1.5. Now, if we work out 1/5 of AB, we can work out what one part of this line is. So 1/5 of AB is 2 divided by 5, which is 0.4, and then minus 1.5 divided by 5 is minus 0.3. So now we know what one part of this line is, or how we get along one part of this line. So to get from B to C, we are going along two parts of this line, or two lots of this vector. So we are going down by minus 0.6, and we're going along by 0.8. So the coordinates of C are going to be 5.8 and 4.9. Cool. Question 5, so we got differentiation. Now I have plenty of stuff on this. Check out the description down below. Y is 2x to the power 10 minus 3 over x squared. We want to find dy by dx. So that means the derivative of y. So let's write y a little bit differently. First of all, let's say that y is 2x to the power of 10 minus, now we're going to write this in power form instead of a fraction. So 1 over x squared is x to the minus 2. 3 over x squared is 3x to the minus 2. Okay, so dy by dx, well, the powers come down and multiply the term, and then the power goes down by 1. So we're going to get 10 times 2x to the power of 9, and then we're going to get minus 2 times minus 3x, and then the power goes down by 1, so down to minus 3. So dy by dx is 20x to the power 9. Now minus 2 times minus 3 is positive 6. So it's add 6x to the minus 3, which we could write as 20x to the 9 add 6 over x cubed. Either form is absolutely fine. Okay, question 6, we want to simplify fully. 15x squared y minus 5xy squared all over 12x minus 4y. So, to be able to simplify things like this, we need to factorize. So let's see what we can do. So, up on top, we have a common factor of 5. So we can try the top as 5x squared. No, we can't. 5 lots of 3x squared y minus xy squared, and at the bottom has a common factor of 4. So at the bottom we can try as 4 lots of 3x minus y. Okay, now the top can still be factorized quite a lot, so let's just do it step by step. There's a common factor of x, so let's take that out. So we get 5x times 3xy minus y squared. And again, that's all over 4 lots of 3x minus y. Still a common factor on top of y. So if we factor that out, we get 5xy times 3x minus y over 4 lots 3x minus y. Now the brackets are common to the top and bottom, so they cancel out. So we just get 5xy over 4. Cool. Question 7. ABCD is a rhombus with side lengths of 8 centimeters. Angle ABC is 60 degrees. Our mission is to work out the area of the rhombus in the form A root B centimeters squared, where A and B are integers. Okay, so not completely obvious this one. What we can do is split Mr. Rhombus in half, like that. So what we've now got is 2 triangles. Now, because it's a rhombus, which is a squat square, we know that side is also 8 centimeters. So we can find the area of triangles like this using trigonometry. So the formula for this is, if you're a triangle and you know an angle, let's call it theta, and you know the 2 side lengths coming out of it, the area is 1/2 AB sine theta. So what we're going to do is work out the area of this triangle. So the area of the triangle is 1/2 times 8 times 8 sine of 60. Now 1/2 times 8 times 8 is 32. Now sine 60, this is one of our exact true values. Sine 60 is root 3 over 2. So this is 32 root 3 over 2, which is 16 root 3. Now the triangle is half the rhombus, so the area of the rhombus is 2 times that, so 32 root 3 centimeters squared. Cool. Okay, next up, the curve y equals 2x cubed minus 3x squared minus 12x add 6 has a maximum point at L minus 113, a minimum point at M 2 minus 14, crosses the y-axis at point N. Now we can actually work that out, which we will do in a sec. The curve crosses the x-axis at 3 distinct points. On the axes below, sketch the graph of this function, labelling L, M and N. So, let's work out first of all the coordinates of n. So on the y-axis, x is equal to 0. So our x coordinate is 0. Now, if we substitute x equals 0 into the function, we would just get left with 6. So n is 0, 6. Okay, let's put the points on then. So L is -1, 13. So it's only a sketch, remember? So we could put L somewhere like that. Now if that's -1, 13, then we know that n is going to be down below it, so somewhere like that. And then m, the minimum, is at 2 minus 14. So that's going to be somewhere like this. Okay, so now we need a curve that goes through the x-axis at 3 points. Now we know it's going to start bottom left, cross, go up to the maximum, through the y-axis. It's going to look something like that. Cool. Question 9. So we got circle theorems here. A, B, C and D are points on a circle. Now we're told about these different angles. We can see that quite clearly on the diagram. We want to prove that AC is a diameter. So, first up, let's think about what that would mean if AC was a diameter. So, when chords come off the ends of a diameter and meet on the circumference, they do so at 90 degrees. So, if AC is a diameter, then angles ABC and ADC will be 90 degrees. Okay, next up. When you have a quadrilateral inside of a circle with all 4 corners on the circumference, it's called a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral add up to 180. So what we can actually do here is work out the value of x. So we know that x add 2x, add 4x, add 3x equals 180. So altogether we've got 10x. So 10x is equal to 180. Therefore x equals 18. So we can now work out the size of these angles. If this is 18 degrees, 4 times 18 is a number like 72. Now 18 and 72 is 90 degrees. So ABC or angle ABC is 180 minus 90, which is 90 degrees. So, there we go, we've proven it. You would want to finish with a statement saying something along the lines of ABC is 90 degrees, therefore AC is a diameter. Cool. Okay, question 10, we've got functions. So I'll put my function stuff down below. F of x is 9x over 2 to the power of minus 1. G of x is square root 1 minus px cubed. Given that f of a third is equal to g of a third, find the value of p. Okay, so first up, f of x is 9x over 2 to the power of minus 1. That power of minus 1 flips the fraction. So f of x is 2 over 9x. Now f of 1/3 is 2 over 9 times a third. 9 times a third is 3, so this is 2/3. Now, G of 1/3 is going to be the square root of 1 minus p times 1/3 cubed. Now 1/3 cubed is 1 over 27. So we can write this as p over 27, like that. Now we know that this whole thing, the square root of 1 minus p over 27, is equal to 2/3. So, square root 1 minus p over 27 is equal to 2/3. So now we want to solve this for p. So first up, square both sides. So we get 1 minus p over 27 is equal to 4 over 9. If we add p over 27 to both sides, we get 1 is equal to 4/9. Add p over 27, take away the 4/9, and then we get 5/9 is equal to p over 27. Now, what we can do here is, well, we want to multiply through by 27. If we first of all though multiplied through by 9, we would get 5 is equal to p over 3. So p is equal to 15. Cool. Question 11, we're dealing with equations of circles. So a circle centre C touches the y-axis at 0, 2. The line y equals k intersects the circle at points 1, k and 5k. Our job is to work out the equation of a circle. So, little recap. A circle centered at A, B with radius R has equation x minus a squared and y minus b squared is equal to the radius squared. So that's the general equation for a circle. Now, we need to track down then the coordinates of the centre. Now the y coordinate is going to be the same as where we touch the y-axis. So the centre has a y coordinate of 2. Now the x coordinate is going to be the midpoint of this line. So the midpoint of that is 5 plus 1 over 2, which is 3. So the centre has coordinates 3, 2. So we can say then that we got x minus 3 squared add y minus 2 squared is equal to the radius squared. Now we need to find the radius. So we know a point that lies on the circle. This point on the y-axis. So when x is 0, y is 2. So if we set x equal to 0 and y equal to 2, and then we end up with minus 3 squared, which is 9. Second bracket disappears, 2 minus 2 is 0, so 9 is equal to the radius squared, so the radius is 3. Now the equation of our circle is x minus 3 squared and y minus 2 squared is equal to 9. Go. Okay, question 12. AB is 4 centimeters, AC is 7 centimeters, and the cos of x is minus 2 sevenths. Work out the length of BC. So this is a non-right angle triangle. We know, well, we don't know an angle, but we know cos of the angle, and we know 2 sides, so it's a job for the cosine rule. Now the cosine rule is this guy, a squared b squared plus c squared minus 2bc cos of it. So let's go side that we're looking for A and substitute our stuff in. So a squared is 4 squared, so 16, and 7 squared is 49, so that's going to give us 65 minus 2 times 4 times 7, so minus 56 times cos of the angle. Cos of the angle is minus 2 sevenths. So we got minus 56 times minus 2 sevenths. So a squared is 65. Now, minus 56 times minus 2 sevenths is going to be positive, because it's negative times a negative, and we are essentially finding 2 sevenths of 56. So 1/7 is 8, 2/7 is 16. So we got 65, add 16, so a squared is 81, therefore our answer is the square root of 81, which is 9. Cool. In question 13, we are rearranging an algebraic fraction. I got a video on this with loads more examples. I'll stick it down below. So we want to rearrange t equals 3w cubed add a over w cubed minus 2 to make w the subject. Good times. 5 marks. So, first step is to multiply through by the bottom of the fraction. So that's going to give us t times w cubed minus 2 is equal to 3w cubed add a. Next step is to expand the brackets. So we get t w cubed minus 2t is equal to 3w cubed add a. Next, we want all the w's on the same side, so I'm going to subtract 3w cubed from both sides. So that's going to give us t w cubed minus 3w cubed. Now we also don't want any terms over here that don't contain w. So I'm going to add 2t to both sides. So we get is equal to 2t add a. Okay, so now we got two terms on the left containing w's. The trick to turning this into one term is to factorize. So we can write this as w cubed times t minus 3 is 2t add a. Now we want to divide both sides by that bracket. So w cubed is 2t plus a over t minus 3. And then the final step is the cube root. So we get w is the cube root of 2t add a over t minus 3. Cool. Question 14. So we have thirds, yay. So we want to rationalise and simplify root 3 minus 7 over root 3 plus 1, giving our answer in the form a plus b root 3, where a and b are integers. So, given that we have a two-term expression on the bottom, we need to use the difference of two squares. So, what we're going to do given that we've got root 3 add 1 on the bottom, we multiply the top and the bottom by root 3 minus 1. Okay, so that's going to give us up on top root 3 minus 7 times root 3 minus 1 all over. Now when you use the difference of two squares, you get the first term squared minus the second term squared. So root 3 squared is 3, 1 squared is 1, so on the bottom we get 3 minus 1, which is 2. Okay, so now we need to expand these brackets on the top. So I would recommend using a table. So put one bracket across the top. So root 3 and minus 7, one bracket down the side, root 3 and minus 1. Now each thing inside the table is a multiplication. So root 3 times root 3 is 3. Root 3 times minus 7. Minus 7 root 3. Then we get minus 1 root 3 down here. And then minus 1 times minus 7 is positive 7. So from that, we've now got 3 and 7, just 10, and then we got minus 7 root 3, minus 1 root 3, so that's minus 8 root 3 all over 2, so that gives us 5 minus 4 root 3. Cool. Okay, 15a. Point A lies on the curve y equals x squared. Add 5x, add 8. Point A has x coordinate minus 4. We want to show that the equation of the normal to the curve at point A is 3y equals x, add 16. So 5 marks, big question. So a normal is a line perpendicular to a curve. So what we're going to need to do is find the gradient of the curve. And then from that we can find the gradient of the normal and find the equation. First thing I'm going to do is find the y coordinate of point A. So when x is minus 4, y is equal to minus 4 squared, which is 16, and 5 times minus 4, which is minus 20, so 16 minus 20 is minus 4, and then we got add 8, so y is 4. Okay, next up, let's find the gradient of the curve. Now to do this, we need to differentiate. So, dy by dx is equal to, so x squared differentiates to 2x, 5x differentiates to 5, and 8 differentiates to 0. So our derivative is 2x add 5. Now the gradient of the curve then at point A is obtained by substituting our x coordinate into the derivative. So the x coordinate is minus 4, so we get 2 times minus 4, add 5. Now that gives us minus 8, add 5, minus 3. Okay, so we know the gradient of the curve at point A. Now, a normal is perpendicular to the curve, so when lines are perpendicular, their gradients multiply together to give us minus 1. So to get the gradient of the normal, well, we know that gradient of normal times minus 3 is equal to minus 1. So, gradient of the normal is minus 1 divided by minus 3. So, 1/3. Right, almost there. Now we need to remember the general equation of a straight line, y equals mx plus c. So here we know y is 1/3 x plus c. Now we need to find the value of c. So to do that, we substitute in the coordinates of the point. So x is minus 4 and y is 4. So, sub in x equals minus 4, y equals 4. Then we get 4 is equal to minus 4/3, add c. 4 in terms of thirds is 12/3. Now if we add the 4/3 to both sides, we get that c is 16/3. So our equation is y equals 1/3 x add 16/3. That's not how they wanted it though. So if we now multiply both sides through by 3, we get 3y is 1x add 16. Cool. Okay, then part B tells us the normal to the curve at A also intersects the curve at point B, and we want to find the value of the coordinates of B. So, when lines or curves meet, they are equal. So, we know them that if y is equal to x squared, add 5x, add 8, so that's the equation of the curve, and I'm going to use the y equals 1/3 x add 16/3 for the normal. 1/3 x add 16/3. Then we think about these equations simultaneously. So both of them here are y equals. So if y is equal to both of these expressions, then the expressions are equal to each other. So we can say x squared add 5x add 8 is equal to 1/3 x add 16 over 3. Now we need to solve this for x. So let's multiply through by 3. So we get 3x squared, add 15x, add 24 is equal to x, add 16. Now it's quadratic, so we need to get everything on the same side. So we're going to subtract x, so we're going to get 3x squared, add 14x, and we're going to subtract 16. So 24 minus 16 is 8. Okay, now we should be able to factorise this. One bracket is going to need a 3x. The other bracket is just going to have a single x. Now then, everything is positive. So two numbers are multiplied together to give us 8. We've either got 1 and 8 or 2 and 4. If we plonk a plus 4 in there, then that's going to give us 4 times 3x, which is going to give us 12x. So then if we put our 2 in there, that is going to get us up to 14x in the middle. Okay, so the right hand bracket tells us what we already knew, x is minus 4. First bracket tells us that 3x add 2 is equal to 0. 3x is equal to minus 2, so x is equal to minus 2 thirds. So that is the x coordinate at B. We now need to find the y coordinate. So, remember the equation of our normal is y equals 1/3 x add 16 over 3. So y is 1/3 times minus 2/3 add 16 over 3. 1/3 times minus 2/3 is minus 2 ninths. 16 thirds in terms of ninths is 48 ninths. So 48 ninths minus 2 ninths is 46 ninths. So B has coordinates minus 2/3, 46 ninths. Lovely. In 16 we've got binomial expansion. So the coefficient of the x to the power 4 term in the expansion of 2x add a to the power of 6 is 60. Work out the possible values of a. So, pretty nasty. We're going to need to use Pascal's triangle, first of all, to find the coefficients of the expansion. So we want the 6th row. So we got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, that's the 4th row, 1, 5, 10, 10, 5, 1, that's the fifth row, and then 1, 6, 15, 20, 15, 6, and 1. Right, so let's work out which one we want. So going in from the left, the 1 would be effectively the x to the power of 0 term. 6 is x to the power of 1. 15 would be the x squared. 20 is the x cubed. 15 would be the x to the power 4 term. So we've got then 15. Now for the x to the power 4 term, we would have 2x to the power 4 times a squared. Now we don't want the x in this, but let's just see what the term is. So this would be 15 times 2x to the power 4 is 16x to the power 4 times a squared. 15 times 16 is 160 and 80, 240. So we know that 240 a squared x to the power 4 is equal to 60 x to the power of 4. So let's get rid of the x to the power 4's. 240 a squared is equal to 60. Divide through by 240. A squared is equal to 60 over 240, which is a quarter. Square root a is plus or minus 1/2. Lovely. Question 17. We are solving 3 variable simultaneous equations. Now, before doing this paper, I haven't done this since my university days. How exciting. Alright, so what we need to do is use one equation to get a letter on its own in terms of the other 2. We're then going to substitute that into the other 2 equations. So, I'm going to use equation 3 to get C on its own. So, to do that, we're going to take away 6a and 3b. So, C is minus 6a minus 3b. Now we're going to rewrite equations 1 and 2 using that substitution. So we got 2a add b minus c. So minus 6a minus 3b, and that is equal to 8. So we've got 2a add b add 6a add 3b is equal to 8. So we get 8a add 4b is equal to 8. Now that, quite nicely, has a common factor. So let's get rid of that as well. We can divide through by 4. So we get 2a and b is equal to 2. Okay, let's do the same for equation 2. So equation 2 is 4a minus 3b minus 2c is minus 9. So we're going to get 4a minus 3b minus 2 lots of whatever c was, minus 6a minus 3b and that is equal to minus 9. Okay, so we've got 4a minus 3b. Now, minus 2 times minus 6a is add 12a. And then minus 2 times minus 3b gives us add 6b. And that is equal to minus 9. So we have got 16a we got minus 3b and 6b, so that's going to give us add 3b is equal to minus 9. Cool. Alright, okay. Let's now write these down. Here's we got 2a and b is equal to 2. Let's call that equation 1. And we've got 16a and 3b is equal to minus 9. Call that equation 2. Okay. So, we either need to get the same number of a or b in each equation. I'm going to go for the b's. So we can turn b into 3b by multiplying by 3. So I'm going to do 3 times equation 1. Now that's going to give us 6a and 3b is equal to 6. Call that equation 3. Okay, so now I'm going to do equation 2 minus equation 3, and that's going to give us 10a is equal to minus 9 minus 6. It's going to give us minus 15. So after all this work, they're not even giving us nice numbers. So a is minus 1.5. Now we can find b. So we know that 2a add b is 2. So 2a is minus 3. So minus 3 add b is equal to 2. b is equal to 5. And then finally, we can also find C. So remember that we said C was minus 6a minus 3b. So C is minus 6 times minus 1.5 minus 3 times 5. Minus 6 times minus 1.5 is 9. So we got 9 minus 3 times 5. So minus 15 is minus 6. So A is minus 1.5, B is 5, C is minus 6 times. Okay, question 18. We want to solve x to the minus 2/3 is equal to 12 1/4. Right, so x to the minus 2/3 means 1 over x to the 2/3. Now if you like, that means 1 over the cube root of x squared. Now 12 1/4 we're going to want to write as an improper fraction. So 12 1/4 is 4 times 12 add 1 over 4. 4 times 12 is 48 and 1 is 49. So we got 49 over 4. So we know 1 over, now I'm actually just going to leave this in power form. So 1 over x to the 2/3 is equal to 49 over 4. Now, because here we only have one term on each side, we can flip the fractions. Now, the only reason that we can do that is because we only have a single term on each side. So that's going to give us x to the 2/3 equals 4 over 49. Now, what we're going to do next is start undoing that power of 2/3. So if we square root both sides, we get x to the 1/3 is equal to the square root of 4 over 49. So that's going to be plus or minus 2 over 7. Now to undo the cube root of x, we're now going to cube both sides. So x, now if we cube this fraction, we get 8 over 7 cubed, which is 7 times 49, 343. So we get x is plus or minus 8 over 343. Lovely. Okay, question 19, we're almost there. Probably shouldn't have done this paper in one go. F of x is 2x cubed minus 12x squared and 25x minus 11. We want to use differentiation to prove f of x is an increasing function for all values of x. So, what that means is, if f of x is an increasing function, then the gradient is always positive. So we should probably start by writing that. So if f of x is an increasing function, and then dy by dx is greater than 0 for all x. So let's find dy by dx or df by dx. So df by dx. So 2x cubed differentiates to 6x squared. So we get 6x squared minus 12x squared differentiates to minus 24x. $25x differentiates to 25, and the 11 at the end differentiates to 0. Okay, so that is our derivative. Now, how can we show that this is always positive? Well, it's quadratic. So what we can do is find the minimum value of a quadratic by completing the square. So, we can say then that this is equal to 6 lots of x squared minus 4x and 25 over 6. Now we can complete the square, so this is 6 x minus 2 squared. Now we have to take away the 2 squared, so minus 4 and 25 over 6. If completing the square is tricky, I've got plenty of stuff on it. Check out the links down below. Right, so we got 6 lots of x minus 2 squared. Now 4 in terms of 6 is 24 6. So we got minus 24 6 and 25 6, which is 1/6. So if we now let this 6 back in, we got 6 lots, x minus 2 squared, and 1. Now, the number at the end of completed square form is either the minimum or maximum value. So, the minimum value of df by dx is 1, which is greater than 0. So f of x is always increasing. Cool. Okay, question 20, the grand finale, thank God. So we want to show that 2 cos squared theta is 2 minus 2 sine squared theta. Okay, so we're going to use one of our trig identities here. Sine squared theta and cos squared theta is equal to 1. Cos squared theta then is equal to 1 minus sine squared theta. So 2 cos squared theta is equal to 2 minus 2 sine squared theta. Hence, solve 2 cos squared theta and 3 sine theta is equal to 3. So, to solve a trig equation like this, you need it to be in terms of just one trig function. So, luckily, we've got the substitution from up above, and that 2 cos squared theta is equal to 2 minus 2 sine squared theta. So, we get 2 minus 2 sine squared theta and 3 sine theta is equal to 3. Now this is quadratic, so we need everything on the same side. We also don't want a negative squared term. So I'm actually going to add everything, or move everything, over to the right. So on the right, we're going to add 2 sine squared. So we would get 2 sine squared. Then we're going to subtract the 3 sine theta. And then we're also going to take away the 2. So we're going to get 3 minus 2 is 1, and then that would equal 0. Right. So, we now need to factorise this. So one bracket is going to need a 2 sine theta. The other one is going to need sine theta. Okay, it's quite nice. The two numbers need to multiply together to give us 1, but we have a negative in the middle, so they're both going to have to be a negative 1. So, we now get 2 equations. 2 sine theta is equal to 1. Sine of theta then is equal to 1/2. Now, to get theta out of that, we would inverse sine 1/2, although this does rely on knowledge of our standard trig values, because it's a non-calc paper. So, this would tell us theta is 30 degrees, or this guy over here, sine of theta is equal to 1, and that happens when theta is equal to 90. So our two values are 30 and 90. Cool. Okay guys, that's the paper done. Hope you found this useful. Hopefully paper 2 is down below in the description. Take it easy. Take care.